Okay, here we go. Declares an integer I, a pointer IP, to an integer, a function f returning an integer, a function FIP returning a pointer to an integer, and a pointer PFI to a function which returns an integer. It is especially useful to compare the last two. The binding of asterisk FIP parenthesis is asterisk parenthesis FIP parenthesis, so that the declaration suggests in the same construction in an expression requires the calling of a function FIP and then using indirection through the pointer result to yield an integer. In the declarator parenthesis asterisk PFI parenthesis, the extra parentheses are necessary, as they are also in an expression, to indicate that indirection through a pointer to a function yields a function, which is then called it returns an integer. As another example, this declares an array of float numbers and an array of pointers to float numbers. Finally, this snap declares a static three-dimensional array of integers with rank 3 multiply 5 multiply 7 in complete detail. Lowercase x 3d is an array of 3 items. Each item is an array of 5 arrays. Each of the later arrays is an array of 7 integers. Any of the expressions lowercase x 3d lowercase x 3d bracket I, lowercase x 3d bracket I bracket j, lowercase x 3d bracket I bracket j bracket k may reasonably appear in an expression. The first three have type array, the last has type int. (8.5) Structure in union declarations. A structure is an object consisting of a sequence of named members. Each member may have any type. A union is an object which may, at a given time, contain any one of several members. Structure and union specifiers have the same form. The cell list is a sequence of declarations for the members of the structure or union. In the usual case, a struct declarator is just a declarator for a member of a structure or a union. A structure member may also consist of a specified number of bits. Such a member is also called a field. Its name is set off from the field name by a column. Within a structure, the objects declared have addresses which increase as their declarations are read left to right. Each non-field member of a structure begins on an addressing boundary appropriate to its type. Therefore, there may be a named host in a structure. Field members are packed into machine integers. They do not straddle words. A field which does not fit into the space remaining in a word is put into the next word. No field may be wider than a word. Fields are assigned right to left on the PDP-11, left to right on the left to right on other machines. A structured declarator with no declarator, only a column and a width. Indicated in unnamed field useful for padding to conform to externally imposed layouts. Is a special case an unnamed field with a width of 0 specifies alignment of the next field at a word boundary. The next field presumably is a field, not an ordinary structure member, because in the later case the alignment would have been automatic. The language does not restrict the types of things that are declared as fields, but implementations are not required to support any but integer fields. Moreover, even int fields may be considered to be assigned. On the PDP-11, fields are not assigned and have only integer values. In all implementations, there are no arrays of fields, and the address of operator ampersand may not be applied to them, so that there are no pointers to fields. The union may be thought of as a structure all of whose members begin at offset 0, and whose size is sufficient to contain any of its members. At most one of the members can be stored in a union at any time. A structure or union specifier of the second form, that is, one of, declares the identifier to be the structure tag or union tag of the structure specified by the list. A subsequent declaration may then use the third form of specifier, one of. Structure tags allow definition of self-referential structures. They also permit the long part of the declaration to be given once and used several times. It is illegal to declare a structure or union which contains an instance of itself, but a structure or union may contain a pointer to an instance of itself. The names of members and tags may be the same as ordinary variables. However, names of tags and members must be mutually names of tags and members must be mutually distinct. Two structures may share a common initial sequence of members. That is, the same member may appear in two different structures if it has the same type in both, and if all previous members are the same in both. Actually, the compiler checks only that a name in two different structures has the same type and offset in both. But if preceding members differ, the construction is non-portable. A simple example of a structured declaration is which contains an array of 20 characters, an integer, and two pointers to similar structures. Once this declaration has been given, the declaration declares S to be a structure of the given sort and SP to be a pointer to a structure of the given sort. With these declarations, the expression refers to the count field of the structure to which SP points, refers to the left subtree pointer of the structure S, and refers to the first character of the toward member of the right subtree of S. 8.6 Initialization. A declarator may specify an initial value for the identifier being declared. The initializer is preceded by equal and consists of an expression or a list of values nested in braces. All the expressions in an initializer for a static or external variable must be constant expressions, which are described in Chapter 15, or expressions which reduce to the address of a previously declared variable, possibly offset by a constant expression. Automatic or register variables may be initialized by arbitrary expressions involving constants, and previously declared variables and functions. Static and external variables which are not initialized are guaranteed to start off at 0. Automatic and register variables which are not initialized are guaranteed to start off as garbage. When an initializer applies to a scalar, a pointer, or an object of arithmetic type, it consists of a single expression, perhaps in braces. The initial value of the object is taken from the expression. The same conversions as for assignment are performed. When the declared variable is an aggregate, when the declared variable is an aggregate, a structure or array, then the initializer consists of a brace enclosed comma-separated list of initializers for the members of the aggregate. What is this? Right. What is this? Hang on. Writing increasing subscript or member order. If the aggregate contains subaggregates, this rule applies recursively to the members of the aggregate. If there are fewer initializers in the list than there are members of the aggregate, then the aggregate is padded with zeros. It is not permitted to initialize unions or automatic aggregates. Braces may be elided. Braces may be elided as follows. If the initializer begins with a left brace, then the succeeding comma-separated list of initializers initializes the members of the aggregate. It is erroneous. It is erroneous for there to be more initializers than members. If, however, the initializer does not begin with a left brace, then only enough elements from the list are taken to account for the members of the aggregate. Any remaining members are left to initialize the next member of the aggregate of which the current aggregate is a part. A final abbreviation allows a char array to be initialized by a string. In this case, successive characters of the string initialize the members of the array. For example, declares and initializes X as a one-dimensional array which has 3 members. Since no size was specified and there are 3 initializers, is a completely bracketed initialization. 1, 3, and 5 initialize the first row of their array y bracket 0, namely y bracket 0, y bracket 0, y bracket 0 bracket 0, comma y bracket 0 bracket 1, and y bracket 0 bracket 2. Likewise, the next 2 lines initialize y bracket 1 and y bracket 2. The initializer ends earlier, and therefore y bracket 3 is initialized with 0. Precisely the same effect could have been achieved by like this. The initializer for y begins with a left brace, but that for y bracket 0 does not. Therefore, 3 elements from the list are used. Likewise, the next 3 are taken successively for y bracket 1 and y bracket 2. Also, initializes the first column of y regarded as a 2-dimensional array and leaves the rest 0. Finally, this word shows a character array whose members are initialized with a string. 8.7 Type names into context to specify type conversions explicitly by means of a case, and as an argument of size, it is desired to supply the name of a data type. This is accomplished using a type name, which in essence is a declaration for an object of that type, which omits the name of the object. To avoid ambiguity in the construction, the abstract declarator is required to be non-empty. Under this restriction, it is possible to identify uniquely the location in the abstract declarator where the identifier would appear if the construction were a declarator in a declaration. The name type is then the same as the type of the hypothetical The name type is then the same as the type of the hypothetical identifier. The name type is then the same as the type of the hypothetical identifier. For example, name respectively the types integer, pointer to integer, array of 3 pointers to integers, pointer to an array of 3 integers, function returning pointer to integer, and pointer to function returning an integer. 8.8 Type diff. Declarations whose storage class is typediff do not define storage, but instead define identifiers which can be used later as if they were type keywords naming fundamental or derived types. Within the scope of a declaration involving type diff, each identifier appearing as part of any declarator therein becomes syntactically equivalent to the type keyword, naming the type associated. With the identifier in the way described in Chapter 8.4. For example, after the construction exists on all legal declarations, the type of distance is int, that of metric is pointer to int, and that of z is a specified structure. ZP is a pointer to such a structure. Type diff does not introduce brand new types, only synonyms for types which could be specified in another way. Thus, in the example above, distance is considered to have exactly the same type as any other int object. Line statements, except as indicated statements, are executed in sequence. 9.1 Expression statement. Most statements are expression statements which have the form like this. Usually, expression statements are assignments or function calls. 9.2 Compound statement or block. So that several statements can be used where one is expected. The compound statement also and equivalently call it block is provided. If any of the identifiers in the declaration list were previously declared, the outer declaration is pushed down for the duration of the block, after which it resumes its force. Any initializations of auto or register variables are performed each time the block is entered at the top. It is currently possible, but a bad practice, to transfer into a block. In that case, the initializations are not performed. Initializations of static variables are performed only once. When the program begins execution inside a block, external declarations do not reserve storage, so initialization is not permitted. 9.3 Conditional statement. The two forms of the conditional statement are: in both cases, the expression is evaluated, and if it is non-zero, the first substatement is executed. In the second case, the second substatement is executed if the expression is zero. As usual, the else ambiguity is resolved by connecting an else with the last encountered else next if. 9.4 While statement. The while statement has the form like this. The substatement is executed repeatedly so long the substatement is executed repeatedly so long as the value of the expression remains non-zero. The test takes place before each execution of the statement. 9.5 Do statement. The do statement has a form like this. The substatement is executed repeatedly. The substatement is executed repeatedly until the value of the expression becomes zero. The test takes place after each execution of the statement. 9.64 statement. The fourth statement has a form like this. This statement is equivalent to like this. Thus, the first expression specifies initialization for the loop. The second specifies a test made before each iteration such that the loop is excited when the expression becomes zero. The third expression often specifies an incrementation which is performed after each iteration. Any or all of the expressions may be dropped. The missing expression 2 makes the implied while clause equivalent to while 1. Other missing Other missing expressions are simply dropped from the expansion above. 9.7 Switch statement. The switch statement causes control to be transferred to one of several statements depending on the value of an expression. It has a form like this. The usual arithmetic conversion is performed on the expression, but the result must be int. The statement is typically compound. Any statement within the statement may be labeled with one or more case prefix. Any statement within the statement may be labeled with one or more case prefixes as follows, where the constant expression must be int. No two of the case constants in the same switch may have the same value. Constant expressions are precisely defined in Chapter 15. There may also be at most one statement prefix of the form. When the switch statement is executed, its expression is evaluated and compared with each case constant. If one of the case constants is equal to the value of the expression, control is passed to the statement following the matched case prefix. If no case constant matches the expression, and if there's a default prefix, control passes to the prefixed statement. If no case matches and if there is no default, then none of the statements in the switch is executed. Case and default prefixes in themselves do not alter the flow of control, which continues unimpeded across such prefixes. To excite from a switch, see break, Chapter 9.8. Usually the statement that is the subject of a switch is compound. Declarations may appear at the head of the statement, but initializations of automatic or register variables are ineffective. 9.8 Break statement. The statement causes termination of the smallest enclosing while, do, for, or switch statement. Control passes to the statement following the terminated statement. 9.9 Continue statement. The statement continue causes control to pass the loop continuation portion of the smallest enclosing while do or for statement, that is, to the end of the loop, more precisely in each of the statement. Like this, a continue is equivalent to go to conti. Following the conti is a new statement. Chapter 9.13. 9.10 return statement. A function returns to its caller by means of the return statement, which has one of the forms. In the first case, the return value is undefined. In the second case, the value of the expression is returned to the caller of the function. It's required. The expression is converted as if by assignment to the type of the function in which it appears. Following of the end of a function is equivalent to a return with no returned value. 9.11 Go-to statement. Control may be transferred unconditionally by means of the statement. The identifier must be a label. Chapter 9.12 located in the current function. 9.12 Label statement. Any statement may be preceded by label prefixes of the form hang on, which serve to declare the identifier as a label. The only use of a label is as a target of a goto. The scope of a label is the current function, excluding any subblocks in which the same identifier has been redeclared. See Chapter 11. 9.13 Null statement. The null statement has the form semicolon. A null statement is useful to carry a label just before the braces of a compound statement, or to supply a null body to a looping statement such as while. 10. External definitions. A C program consists of a sequence of external definitions. An external definition declares an identifier to have storage class extern by default, or perhaps static, and a specifier type. The type specifier, Chapter 8.2, may also be empty, in which case the type is taken to be int. The scope of external definitions proceeds to the end of the file in which they are declared, just as the effect of declarations persists to the end of a block. The syntax of external definitions is the same as that of all declarations, except that only at this level may the code for functions be given. 10.1 External function definitions. Function definitions have the form: the only SC specifiers allowed among the detail specifiers are extern or static. See Chapter 11.2 for the distinction between them. A function declarator is similar to a declarator for a function returning, except that it lists the formal parameters of the function being defined. The function body has a form. The identifiers in the parameter list, and only those identifiers, may be declared in the declaration list. Any identifiers whose type is not given are taken to be int. The only storage class which may be specified in register. The only storage class which may be specified is register. If it is specified, the corresponding actual parameter will be copied, if possible, into a register at the outset of function. A simple example of a complete function definition is here. Int is the type specifier. Max parenthesis a, b, c is the function declarator. Int I a, b, c is the declaration list for the formal parameters. Break is is the block giving the code for the statement. C converts all float actual parameters to double. So formal parameters declared float have their declaration adjusted to read double. Also, since a reference to an array in any context, in particular is an actual parameter, is taken to mean a pointer to the first element of the array. Declarations of formal parameters declared array of are adjusted to read pointer to Finally, because structures, unions, and functions cannot be passed to a function, it is useless to declare a formal parameter to be a structure, union, or function. Pointers to such objects are, of course, permitted. 10.2 External data definitions. An external data definition has the form like this. The storage class of such data may be external, which is the default, or static, but not auto or register. 11. Scope rules. A C program need not all be compiled at the same time. The source text of the program may be kept in several files, and pre-compiled routines may be loaded from libraries. Communication among the functions of a program may be carried out both throughout explicit calls and through manipulation of external data. Therefore, there are two kinds of scope to consider. First, hang on. What may be called the lexical scope of an identifier, which is essentially the region of a program during which it may be used without drawing and defined identifier dialectics. And second, the scope associated with external identifiers, which is characterized by the rule that references to the same external identifier are references to the same object. 11.1 Lexical scope. The lexical scope of identifiers declared in external definitions proceeds from the definition through the end of the source file in which they appear. The lexical scope of identifiers, which are formal parameters, persists through the function with which they are associated. The lexical scope of identifiers declared at the head of blocks persists until the end of blocks. The lexical scope of labels is the whole of the function in which they appear. Sorry about the dog crying. Hang on. Because all references to the same external identifier refer to the same object. See chapter 11.1. The compiler checks all declarations of the same external identifier for compatibility In effect, their scope is increased to the whole file in which they appear. In all cases, however, if an identifier is explicitly declared at the head of a block, including the block constituting a function. Hang on. Sorry. Any declaration of that identifier outside the block is suspended until the end of the block. Remember also, Chapter 8.5 that identifiers associated with ordinary variables on the one hand and those associated with structured unit members and tags on the other form two disjoint classes which do not conflict. Members and tags follow the same scope rules as other identifiers. Type div names are in the same class as ordinary identifiers. They may be redeclared in inner blocks, but an explicit type must be given in the inner declaration. The int must be present in the second declaration, or it would be taken to be a declaration with no declarators in type distance. 11.2 Scope of externals. In a function refers to an identifier declared to be external, then somewhere among the files or libraries constituting the complete program, there must be an external definition for the identifier. All functions in a given program which refer to the same external identifier refer to the same object, so care must be taken that the type and size specified in the definition are compatible with those specified by each function which references the data. The appearance of the external keyword in an external definition indicates that storage for the identifiers being declared will be allocated in another file. Thus, in a multi-file program, an external data definition without the external specifier must appear in exactly one of the files. Any other files which wish to give an external definition for the identifier must include the external in the definition. The identifier can be initialized only in the declaration where storage is allocated. Identifiers declared static at the top level in external definitions are not visible in other files. Functions may be declared static. 12. Compiler control lines. The C compiler contains a preprocessor keyboard. The C compiler contains a preprocessor capable of macro substitution, conditional compilation, and inclusion of named files. Lines beginning with hash communicate with this preprocessor. These lines have syntax independent of the rest of the language. They may appear anywhere and have effect which lasts independent of scope until the end of the source program file. 12.1 Token replacement, a compiler control line of the form. Note: no trailing semicolon causes the preprocessor to replace subsequent instances of the identifier with the given string of tokens. Line of the form, where there is no space between the first identifier and the is a macro definition with arguments. Subsequent instance of the first identifier followed by a sequence of tokens delimited by commas and a parenthesis are replaced by the token string in the definition. Hang on. Each occurrence of an identifier mentioned in the formal parameter list of the definition is replaced by the corresponding token string from the call. The actual arguments in the call are token strings separated by commas. However, commas encoded strings or protected by parentheses do not separate arguments. The number of formal and actual parameters must be the same. Text inside a string or a character constant is not subject to replacement. In both forms, the replacement string is rescanned for more defined identifiers. In both forms, a long definition may be continued on another line by writing backslash at the end of the line to be continued. This facility is most valuable for definition of manifest constants using control line of the form like this causes the identifier's preprocessor definition to be forgotten. 12.2 File inclusion, a compiler control line of the form like this causes the replacement of that line by the entire contents of the file name. The named file is searched for first in the directory of the original source file, and then in a sequence of standard places. Alternatively, a control line of the form searches only the standard places and not the directory of the source file. 12.3 Conditional completion, a compiler control line of the form checks whether the constant expression, see Chapter 15, evaluated to non-zero. A control line of the form checks whether the identifier is currently defined in the preprocessor, that is, whether it has been the subject of a hash-defined control line. A control line of the form checks whether the identifier is currently undefined in the preprocessor. All three forms are followed by an arbitrary number of lines, possibly containing a control line, and then by a control line. If the checked condition is true, then any lines between #else and #endif are ignored. If the checked condition is false, then any lines between the test and #else or lacking an #else the hash and if are ignored. These constructions may be nested. Sorry. .4 Line control. For the benefit of other preprocessors which generate C programs, a line of the form like this causes the compiler to believe, for purposes of error diagnostics, that the line number of the next source line is given by the constant and the current input file is named by the identifier. If the identifier is absent, the remembered file name does not change. Certain implicit declarations. It is not always necessary to specify both the storage class and the type of identifiers in a declaration. The storage class is supplied by the context in external definitions and in declarations of formal parameters and structure members. In a declaration inside a function, if a storage class but no type is given, the identifier is assumed to be int if a type but no storage class is indicated. The identifier is assumed to be auto. An exception to the later rule is made for functions, since auto functions are meaningless, C being incapable of compiling C being incapable of compiling code into the stack. If the type of an identifier is function returning, it is implicitly declared to be external. In an expression, an identifier followed by and not already declared is contextually declared to be function returning int. What happened? 14 types revisited. This section summarizes the operations which can be performed on objects of certain types. 14.1 Structures in unions. There are only two things that can be done with a structure or a union. Name one of its members by means of the dot operator, or take its address by unary ampersand. Other operations, such as assigning from or to it, or passing it as a parameter, draw an error message. In the future, it is expected that these operations, but not necessarily others, will be allowed. Chapter 7.1 says that in a direct or indirect structure reference with dot or arrow, the name on the right must be a member of the structure named or pointed to by the expression on the left. To allow an escape from the typing rules, this restriction is not firmly enforced by the compiler. In fact, hang on. Any L value is allowed to. In fact, any L value is allowed before dot, and that L value is then assumed to have the form of the structure of which the name on the right is a member. Also, the expression before a arrow is required only to be a pointer or an integer. If a pointer, it is assumed to point to a structure of which the name on the right is a member. If an integer, it is taken to be the absolute address in machine storage units of the appropriate structure. Such constructions are non-portable. 14.2 Functions. There are only two things that can be done with a function: call it or take its address. If the name of a function appears in an expression not in the function name position of a call, a pointer to the function is generated. Thus, to pass one function to another, one may say, then the definition of G might read: notice that f must be declared explicitly in the calling routine since its appearance in G parenthesis f was not followed by like this. 14.3 Arrays, pointers, and subscripting. Every time an identifier of array type appears in an expression, it is converted into a pointer to the first member of the array. Because of this conversion, arrays are not L values. By definition, the subscript operator bracket is interpreted in such a way that E1 bracket E2 is identical to asterisk like this. Because of the conversion rules which apply to plus, if E1 is an array and E2 is an integer, and then E1 bracket E2 refers to the E2's member of E1. Therefore, despite its asymmetric appearance, subscripting is a commutative operation. Okay guys, I think here we need a break to have a cup of tea. See you guys. Goodbye.